In this video, we're going to learn how to graph an exponential function. Now, in order to graph an exponential function, we're first going to start out by just plotting several x values and see what y values come up, and then we'll form an opinion about the shape of the graph to help us graph further exponential functions. I'll address the information in the bottom right as I work through this first example. So first, I want to graph y is equal to 2 to the x. I'm actually going to start with the middle point here at 0. When I plug in 0 for x, I get 2 to the 0th power, which is equal to 1. Anything raised to the 0th power is 1. So when I go to graph, I can see that my y-intercept is at 0, 1. Now, as I use larger powers, like 2 to the first power, that's equal to 2. 2 to the second power, that's 4. 2 to the third power is 8. So I'll plot a point at for when x is 1, y is 2. When x is 2, y is 4. And when x is 3, y is 8. Now we can see that it's increasing very rapidly on the right side. But let's see what happens as we go to the left side. When I plug in -1 and gets 2 to the -1 power, we have to put that in the denominator, so 1 over 2, which is equal to a 0.5, so halfway up. So at -1, I'm halfway to 1. If I go backwards to -2, 2 to the -2, that's 1 over 2 squared, which is 4, which is 0.25. So even lower, closer to 0. So it's not necessarily touching 0 yet. If I do 2 to the -3, that's 1 over 2 cubed, which is 1 over 8, which is 0.125, so even closer to 0. You'll see here I'm starting to flatten out along that x-axis. But what you're going to notice is even with 2 to the -4, if I kept going, that's 1 over 2 to the 4, which is 1/16, which is 0.0625. Even if I keep going, I'll just keep getting closer and closer to 0, but I'll never cross that axis, the x-axis. So when I draw this, it's kind of flat along the x-axis and then curves upward. But it flattens out along the x-axis, and this is referred to as a horizontal asymptote. Meaning it'll approach it, but it won't touch it. It'll use it as a guide for large negative values of x to flatten out against. But then it'll grow very quickly off to the right. Now, so whenever that b value that's being raised to the x is greater than 1, this represents exponential growth for the graph, because it's going to grow to the right. Now let's see what happens when you pick a b value that's between 0 and 1. It's like 1/3. Now when I plug in 0 for x, I get 1/3 to the 0th power, which again, anything raised to the 0th power is 1. So I have a point at 0, 1. And when I plug in 1, I get 1/3 to the first power, which is just 1/3, or approximately 0.33. So it gets smaller. And if I plug in 1/3 squared, when I plug in a 2 for x, I get 1/9, which is approximately 0.11. This is even closer to the x-axis. And again, it's never going to actually hit that x-axis. There's no power I'll be able to pick for 1/3 that would actually make this equal to 0 or less than 0. So it's just going to flatten out against the x-axis again. So I have a horizontal asymptote along the x-axis again. Now if I go backwards, I plug in -1, so I have 1/3 to the -1 power. One thing you can also think about with negative exponents is it uses the reciprocal of the number. So like 2 to the -1 was 1/2, the reciprocal of 2. So 1/3 to the -1 would be 3 over 1, 3. So at -1 is equal to 3. And then when I do 1/3 to the -2nd power, that's going to be equal to 3 squared, which will be 9. So -2, 9. And this time when I graph it, it's not going to go up to the right. It's actually going to flatten out to the right. Oop. I'll fix that in just a second. In this situation is known as exponential decay, because now it's going down and flattening out to the right. So this is referred to as exponential decay, whenever b is between 0 and 1. Now let's see what happens when a, the number that's in front of the exponential function, is something other than 1. So let's say it's 2 versus 3 to the x. So if I start with 0, I'll get 2 times 3 to the 0th power. So that's just 2 times 1, which is 2. So my y-intercept is at 0, 2. And when I plug in 1, I get 2 times 3 to the 1st, which is just 2 times 3, 6. So at 1, it goes up to 6. And then 2 times 3 to the -1 gives me 2 times 1/3, which is 2/3, which is about 0.67. So -1 is about 0.67. You're going to notice that it should still act like it's flattening out against the x-axis again. If I were to keep picking bigger and bigger values, or more negative values for x. And it grows off to the right. And again, that makes sense because that 3 is bigger than 1. So we say that it's exponential growth since it's bigger than 1. And what it turns out is that a value actually corresponds with the y-intercept every time. So every time you plug in 0, whatever that number is in front of the exponential function is the y-intercept. Over here, it was 1. Over here, it was 2 because I had 2 in front of the 3 to the x. And typically, you only need about 3 points to graph an exponential function. When you plug in -1, you just put a over b, which makes sense. You get 2 over 3. And then when you plug in 1, you just do 2 times 3 for the other point, which is 6. And once you have those 3 points, you have enough to kind of make an opinion about the graph. Now, the domain of every exponential function will always be -infinity to infinity, or all real numbers. You can plug in any x value that you want to. The range is always going to be positive values. So 0 to infinity, or y is greater than 0, because it's always going to be above the x-axis for this form of an exponential function. And you'll always get a horizontal asymptote at y equals 0, also known as the x-axis. And this is how you graph an exponential function.